please use this handout to follow along with the lesson. This lesson continues on the theme of trigonometry. Last time we looked at using the Pythagorean theorem to find a missing side length in a right triangle. We're going to continue with finding side lengths, but this time, instead of using the Pythagorean theorem, we're going to use trig ratios or trigonometric ratios. And you would have seen these in grade 10, but if you've forgotten or you just are a little fuzzy on the details, that's fine. That's the whole point of this lesson, is to review all that stuff. So just like Pythagorean theorem that only worked with right triangles, the same is true for these ratios, sine, cosine, and tangent. They only work if there's a right angle in your triangle. Now, you would have seen these ratios in grade 10, but sine of an angle is the opposite over the hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So we need to be comfortable with applying these labels, opposite, adjacent, hypotenuse, so that we can place our side lengths in the correct spot. We also need to be comfortable with the idea that this symbol represents an angle. This is a Greek letter. It's the Greek letter theta, and it's usually used by mathematicians to indicate an angle. Okay, so these labels. Well, hypotenuse. We covered that in the last lesson. Where's the hypotenuse? It's directly across from the right angle. So here in this triangle, this is the hypotenuse. In this triangle, this is the hypotenuse, directly across from the right angle. What about opposite? What does that mean? Well, opposite is the side that is opposite the angle that you're using. The angle that you're using is the angle you're using here, which is theta. So in this triangle, this is theta. So the side that's opposite is on the opposite side of the triangle. It's directly across. So there's the opposite side in this triangle. Over here, this is my angle. So which side is opposite? It's directly across. This is the opposite side. So hypotenuse doesn't change. It's just the side that's across from the right angle. But opposite changes depending on where your angle is located. The adjacent side. Adjacent means beside. So this is the side length that is beside your chosen angle. Really though, if you can locate the hypotenuse and the opposite side, the adjacent is just the other side. So over here, this is the adjacent side. You got to be very comfortable in applying these labels in order to use the trig ratios to solve problems. And I'll illustrate this with some examples. Hopefully it'll make more sense after that. Okay, first example, determine the length of side A. There's side A. We're trying to find this side length. Round the answer to 1 decimal place. Okay, so we have an angle, we have one side, and we want to know this side. We don't know the length of this side, so we can't use Pythagorean theorem. We have to use a trig ratio. So the question is, do we use sine, cosine, or tangent? Well, this is where labeling the sides comes in handy. So I'm going to start by labeling my hypotenuse. Then I want to label my opposite side. So here's my chosen angle, the 36-degree angle. Opposite is directly across, so this is my opposite side. And the side left over is my adjacent side. So I don't have any information about how long the hypotenuse is, and I'm not interested in finding the hypotenuse. I'm interested in finding the length of the opposite side, and I'm given the length of the adjacent side. So I have to think which of my trig ratios utilizes opposite and adjacent. Well, if you go back up and look at the different ratios, this one uses opposite and hypotenuse, so I don't want to use that one. This one uses adjacent and hypotenuse, so I can't use that one. This one uses opposite and adjacent. So tangent, the tangent ratio is my trig ratio of choice for this question. So tangent is opposite over adjacent. So I would start with that, plug in the numbers that I know, and now I can start to calculate my answer. Remember, theta is the angle, so that's why there's a 36 degrees here. Opposite was A, and adjacent was 26. So now we need to solve for A. Well, this is where solving proportions a couple lessons ago, that whole thing comes in really handy here. What do I mean? Well, tan 36 is a number. And anytime you have a number, you can write it as a fraction over 1. So now I have a proportion like I saw a couple lessons ago. To solve for A, I can just do my cross multiply and divide. So I'll go 26 times tan 36 and divide by 1. Now if you're keen here, you'll realize if you divide by 1, it's just unchanged. So really, you just have to do 26 times tan 36. And then you'll get your answer for A. Now you have to be familiar with how your calculator works. Some calculators, you can just type this whole thing in exactly as it looks. You can just write 26 bracket tan 36, close the bracket, hit equals, and it'll spit out the answer for A. Other calculators, you have to be a little bit more careful. You might have to type in 36 and then press the tan button and then go times 26 and then hit equals. So if you're having trouble with your calculator, you got to let me know. You should be getting this as your answer. And if you don't get this, then you let me know and I'll help you figure out how to use your calculator properly. But if you've got your calculator figured out, try these next 3 on your own. Now it says determine the length of F, so side F, not to be confused with this angle F. Recall from grade 10, a lowercase letter tells you what side it is. That's opposite to angle F. So this is side F here. Here's angle F. So this is side F. Here's angle F. This is side F. So you're finding side F in each of these 3 triangles. Remember, you gotta label your sides first, figure out which trig ratio to use based on which sides you have and which one you want, and then plug in your numbers and solve. So pause the video and try it on your own, and then come back and see how you did. So here are my final answers circled. If you got those, you're good to move on. If you didn't get these, here's my explanation of how I got it. So I labeled my sides. There's my angle. Directly across is opposite. This is hypotenuse, so that means this is adjacent. So I'm using opposite and adjacent. That's tangent. Tangent is opposite over adjacent. So now I'm going to use this formula, plug in what I know. Well, theta is 50 degrees. Opposite is F. Adjacent is 5. So that's where this came from. Then I remember I can write this as a fraction over 1. To solve for F, I cross multiply 5 times tan 50, divide by 1, which is just 5 times tan 50. Do that in my calculator, I get 5.96 as my answer. For the next one, there's the right angle, that's hypotenuse. There's my angle that I'm using, so that's opposite. The side left over is adjacent. So adjacent and hypotenuse, that's cosine, because cosine uses adjacent and hypotenuse. Fill in what I know. Theta is 30 degrees. adjacent is 4, hypotenuse is f. So that's where this comes from. It's a fraction over 1, so to solve for f, cross multiply 4 times 1, which is just 4, divided by cos 30. So that's where this comes from. Do that in my calculator, I get 4.6. And over here, there's my hypotenuse, there's my angle, so that's opposite. I'm using opposite and hypotenuse, so I choose sine because sine theta is opposite over hypotenuse. Theta is 45 degrees, opposite is 7.2, hypotenuse is f. Fraction over 1, to solve for f, cross multiply 7.2 times 1, that's just 7.2, divide by sine 45, I get 10.2. So if you have any questions about that, you need to ask. Let me help you, and I'll do my best to help. Otherwise, move on, flip the page over. In this last question, I'd like you to try it. It says, solve the following triangle. So when you are to solve a triangle, it means figure out all the information. So some of it you're given. You're given this angle is 90 degrees, this angle is 60 degrees. You're given this side length is 25 meters, but you don't know this side length, you don't know this side length, and you don't know this angle. So why don't you just pause the video, try to figure out as many of those missing things as you can. You've got one missing angle and two missing sides. Figure out as many of those as you can, and then you can check back in to see my full solution. Now, you may have solved this a little bit differently than me, but as long as we're getting the same answers, then we should be good. What I did was I started with this angle, and I know I didn't go over this rule with you, but I was hoping that you would remember it, that all the inside angles of a triangle have to add up to 180 degrees. So to find this missing angle, we have to take 90 and 60 away from 180. And so I got 30 degrees. To find side A, I started with this given angle and I labeled my sides. Well, that's the hypotenuse, that's the opposite, this is adjacent. So I want adjacent, I have hypotenuse, that's cosine. So cosine of 60 is A over 25. To solve for A, it's 25 times cosine 60. And that gives me 12.5. So A is 12.5 meters. Now you could use a trig ratio again to find B, but I chose to just use Pythagorean theorem. Because I have a right triangle, I know two sides, I can figure out the third using Pythagorean theorem. Just remember, this is the hypotenuse, so it goes in the hypotenuse spot. And then we can just solve for B. If you have any trouble with that, let me know, and I can do my best to help. But I'm hoping that by the end of this lesson, you are comfortable with labeling your triangle with opposite, adjacent, hypotenuse, determining which trig ratio to use, sine, cosine, or tangent, and then being able to plug in your numbers and do the math to solve for your unknown side. If you have trouble with that, let me know. I'll do my best to help. Otherwise, move on to the practice problems for this lesson.